Imagine a world where information travels instantly. No lag time, no buffering, just pure, instantaneous communication. This isn't science fiction. This is the promise of quantum teleportation, a mind-blowing phenomenon rooted in the heart of quantum mechanics. It's a realm where the rules of our everyday world dissolve, where particles whisper secrets across vast distances, where the very fabric of reality seems to bend. We often picture atoms as tiny solar systems, with electrons orbiting a nucleus. But this picture is too simple. It's a useful model, but the quantum world is far stranger and more wondrous. In the quantum realm, particles don't just exist in one state, they exist in a superposition of states, meaning they can be in multiple places at once. It's like flipping a coin. It's both heads and tails until we look at it. This bizarre behavior is key to quantum teleportation. Instead of teleporting physical matter, we're teleporting information. Think of it like sending a blueprint of an object rather than the object itself. This blueprint contains all the information needed to recreate the object at the receiving end. Quantum teleportation hinges on a mind-boggling phenomenon called entanglement. Two entangled particles are linked in a way that defies classical physics. They share a fate, no matter how far apart they are. Imagine two coins flipped at the same time, always landing on the same side. Even if one coin is on Earth and the other is on Mars, they are connected. This connection, this spooky action at a distance, is the bedrock of quantum teleportation. In the realm of science fiction, teleportation conjures up images of shimmering figures dematerializing and reappearing across galaxies. But quantum teleportation isn't about teleporting atoms, it's about teleporting information. It's about transferring the quantum state of a particle from one location to another without physically moving the particle itself. Think of it like faxing a document. You're not sending the physical paper, but the information encoded on it. Similarly, in quantum teleportation, we're sending the quantum information encoded in a particle's state. This information could be anything: the polarization of a photon, the spin of an electron, or even the complex state of an atom. Now let's step into the world of cutting-edge science. Researchers at Oxford University have achieved a groundbreaking feat teleporting quantum information within a computer chip. This might sound like a small step, but it's a giant leap for quantum computing. It opens up a realm of possibilities from unhackable communication networks to lightning-fast quantum computers. Imagine a world where hackers are rendered powerless, where the very laws of physics protect our data. That's the promise of quantum communication. By exploiting the bizarre nature of entanglement, we can create communication channels that are inherently secure. Any attempt to eavesdrop would disturb the entangled particles, alerting the sender and receiver to the intrusion. The Oxford experiment, a symphony of lasers, mirrors, and ultra-cold atoms, achieved an astonishing 91% fidelity in teleporting quantum information. Imagine transmitting a complex message, a blueprint for a revolutionary technology, with only a 9% chance of error. That's the level of accuracy we're talking about. They achieved this by cooling atoms to a fraction of a degree above absolute zero. At these frigid temperatures, the atoms become sluggish, their movements slowing to a quantum crawl. This allows scientists to manipulate them with exquisite precision, entangling them and controlling their quantum states. Think of it like trying to write a message on a vibrating platform versus a stable table. The calmer the atoms, the more accurately they can manipulate their quantum states, like writing a message with atomic precision. This breakthrough isn't just about achieving record-breaking fidelity, it's about practicality. By demonstrating teleportation within a chip, the Oxford team has brought quantum communication one step closer to reality. It paves the way for building practical, scalable quantum computers and networks. Imagine a world where every online transaction, every sensitive piece of data, is protected by the unbreakable laws of quantum mechanics. This is the tantalizing possibility offered by quantum cryptography. In a world increasingly reliant on digital communication, internet security is paramount. Our financial transactions, personal data, and even national secrets flow through a complex web of networks, vulnerable to hackers and cyber attacks. Quantum cryptography offers a revolutionary solution. By encoding information in the quantum states of entangled particles, we can create communication channels that are inherently secure. Any attempt to intercept or eavesdrop on the transmission would disrupt the delicate entanglement, alerting both the sender and receiver to the breach. This is not some far-off futuristic fantasy. Quantum cryptography is already being tested in real-world settings. Banks are exploring its potential to secure financial transactions. Government agencies are investigating its use in protecting classified information, and research networks are using it to create ultra-secure communication links. Section 5. Quantum supercomputing crunching numbers at warp speed. Beyond secure communication, quantum teleportation holds the key to unlocking unprecedented computational power. Imagine a computer that can solve problems in seconds, problems that would take classical computers billions of years. This is the promise of quantum computing. Quantum computers harness the strangeness of the quantum world to perform calculations in ways that classical computers can only dream of. While classical computers rely on bits, which can be either 0 or 1, quantum computers use qubits. Qubits, thanks to superposition, can be 0, 1, or both simultaneously. This mind-bending ability allows quantum computers to perform multiple calculations at once, exponentially increasing their processing power. Imagine searching through a maze. A classical computer has to try each path one at a time. A quantum computer can explore all paths simultaneously, finding the solution much faster. Quantum teleportation plays a crucial role in this process by enabling the transfer of quantum information between different parts of the computer. This allows for the creation of complex quantum circuits, the building blocks of sophisticated quantum algorithms. Section 6. The hurdles we face. The path to a quantum future is not without its obstacles. Building large-scale, reliable quantum computers is a monumental task, fraught with technical challenges. One of the biggest challenges is maintaining the delicate state of entanglement. Entangled particles are notoriously fickle. The slightest disturbance from their environment can cause them to lose their quantum connection, a process known as decoherence. Imagine trying to balance a spinning coin on its edge. The slightest vibration or puff of air can cause it to topple over. Similarly, entangled particles are extremely sensitive to their surroundings, making it difficult to maintain their delicate state for extended periods. Another hurdle is scalability. While we've been able to teleport quantum information over small distances, scaling up this technology to create practical quantum networks is a daunting task. Imagine trying to build a bridge across a vast canyon. Building a small-scale model is one thing, but constructing a full-sized bridge that can withstand the elements is a completely different challenge. Similarly, building large-scale, fault-tolerant quantum networks requires overcoming significant engineering and technological barriers. Section 7. A future forged in the quantum realm. Despite these challenges, the future of quantum teleportation shines brighter than ever. Scientists and engineers around the world are making remarkable progress. New materials, innovative techniques, and relentless ingenuity are pushing the boundaries of what's possible. Imagine a future where quantum computers unlock the secrets of the universe, simulating the birth of stars, designing life-saving drugs, and revolutionizing materials science. Imagine a world where quantum communication enables us to share information with unprecedented security and speed, connecting us in ways we never thought possible. This is not a pipe dream. It is the inevitable outcome of our insatiable curiosity, our relentless pursuit of knowledge. The quantum revolution has begun, and we are the voyagers, embarking on a journey into the unknown, driven by the same spirit of exploration that has propelled humanity from the savannas of Africa to the surface of the moon. Section 8. The moral implications of quantum advancements. As we stand on the cusp of this quantum revolution, we must also grapple with the profound ethical implications of these transformative technologies. The same power that can unlock unprecedented knowledge and connectivity can also be used for malicious purposes. Imagine a world where quantum computers crack the encryption codes that protect our financial systems, our personal data, our national security. Imagine a world where quantum weapons, capable of unparalleled precision and destructive power, fall into the wrong hands. These are not just hypothetical scenarios, they are real possibilities that we must confront head-on. As we develop these powerful technologies, we must do so responsibly, ethically, and with a keen awareness of their potential impact on society. We need to establish international collaborations, ethical guidelines, and regulatory frameworks to ensure that these technologies are used for good, not for harm. The future of humanity may depend on it. Section 9. Our Cosmic Inheritance. The quest to unravel the mysteries of the quantum world is more than just a scientific endeavor, it's a testament to the indomitable spirit of human curiosity, our innate desire to understand the universe and our place within it. From the ancient Greeks who first pondered the nature of reality, to the modern-day physicists who explore the subatomic realm, humanity has always been driven by a thirst for knowledge, a yearning to push the boundaries of the unknown. The discoveries we make in the quantum realm will not only transform our technological capabilities, they will also reshape our understanding of the universe and our place within it. They will challenge our assumptions about the nature of reality, the limits of knowledge, and the very essence of what it means to be human. This is our cosmic inheritance, the legacy we leave to future generations. Let us embrace it with wisdom, with courage, and with a sense of wonder befitting the vastness of the cosmos itself.